All right, and welcome to Decred Assembly episode 21. Today we have a really exciting episode. We're going to be touching on simple payment verification, or SPV. And before we get into it, I want to introduce the people that we have on the show. We have Jake.
Hello.
We have Josh,
What's up?
J. Rick, and myself, Trace. But yeah, one fun thing I'm wanting to do more with the show is, the past couple episodes, we've had the developers from Company Zero come on and explain a little bit about what's been going on with the project, but also to give a brief introduction of how they got involved, or what things that they like about Decred, and then a hobby of theirs that they have. So I was wondering if you'd be willing to share.
Yeah, so I got involved with Company Zero before it was Company Zero, back when it was conformal still. And we were working on Bitcoin software at the time, and we just transferred over to working on Decred based on the problems that we were experiencing and seeing in Bitcoin. Yeah.
Great. Any hobbies?
I mean, I like to game a little bit, but that's about it.
Fair enough.
So am I expected to answer questions about my hobbies?
I mean, it doesn't have to be anything specific, and if you don't want to try and talk.
Let's see. I've been doing this for a long time. We lost a lot of money before we made money. That was exciting. And in terms of hobbies, I like to hide in my basement. I like to work on computer security really in my spare time. So it's other people are like, oh, I like to get out and do this and then. It's like I like to hide in my basement and mess with computers. And I think that J-Rick may or may not have a basement. I'm not sure, but I think that everything else still applies with him. I guess the other thing I like to do is I like to climb up mountains without equipment. I'm not quite a free climber. I don't have the huevos for that, and I like to go places where I can go without equipment, and that's really exciting to me because I don't have to I'm not like tethered to the virtual world via solid state computer hardware where it's like, oh, if you kick the thing, it's going to break. It's like, no, I'm out here. I got my hands on the rocks. I could fall down and I could die. So that's what I like to do.
Yeah, that's awesome. Yeah, so getting right into it, this episode is specific to SPV, or simple payment verification. So if one of you would be willing, can you give an overview of what simple payment verification is? For those of you familiar with cryptocurrency, this isn't necessarily a new concept. It was outlined a little bit in Satoshi Nakamoto's white paper. It's a compressed way to verify transactions, but if you're able to give a little more of an in-depth overview.
Yeah, so SPV is essentially you're taking a wallet and you're trying to get all the relevant transactions for a wallet without necessarily downloading the entire blockchain. So this has been done in Bitcoin for a very long time, and it was done with server-side Bloom filtering. So you upload a data set to a Bitcoin node or several different Bitcoin nodes, and they tell you, yeah, these transactions match, and they send the transactions back, and that's how your wallet, can update its balance and stuff. So that's kind of where we are currently at with SPV, and then I guess we're going to talk about different stuff, how we do it.
Yeah, and maybe to embellish a little bit would be that what we're doing, say, differently than Bitcoin, right, is that what Jarek's talking about is server-side filtering, so that not all the transaction notifications get streamed to the client. And then what we're doing is we're doing client-side filtering, which is something that's been recently added to Bitcoin by the Lightning Labs developers. So that in a broad stroke, we're trying to have all the benefits of SPV without the the detriments of server-side filtering that Jarek just described.
And generally, just on the Bitcoin side of things, simple payment verification, not necessarily with the implementations from the Lightning Labs that you guys are working on. What is the general strength of simple payment verification?
It allows wider access to many more devices, especially mobile devices where you don't want to have a full blockchain and a fully validating node. In an SPV implementation, a client implementation, you're only validating the proof of work in the header chain. And that's quite easy to do. Doesn't require a lot of resources to do that.
Yeah, I mean, the upshot of SPV is you want to download as little as possible, but still get all the relevant transaction data you need. And just like Jarek's pointed out, the proof of work is in the header so that you can verify that the chain has a valid proof of work to it without necessarily downloading the entire block, verifying all of the transactions, making sure, you know, everything Merkel's down to the root and it matches the stuff in the header. So it's basically making sure the headers fit together properly, and then from these sorts of these thin pieces of data like the header or the compact filter, you can infer the rest of the data you need and only download data as necessary.
No, that's great, and definitely having a smaller piece to work with definitely opens up the realm of possibilities as far as using mobile devices and using it, you know, on more portable devices overall. And so with that, you know, obviously SPV has been implemented for a while on Bitcoin side of things. Different projects are implementing SPV, but how is Decred doing it differently? What's different than the normal SPV implementation?
So as touched on earlier, we're not using a server-side filtering. Instead of uploading a filter to a node and it giving you back transactions, instead a predetermined filter is created for every block based on the transactions in that block. Those filters are then downloaded to your client, to the wallet. The wallet is able to locally match against a private data set. It doesn't upload this data set anywhere else. It's able to match against that. If it matches, it then fetches the block, scans over all transactions, adds anything that's relevant. There might not be anything relevant. It could be a false positive, but that is how our implementation works. And this is based off of BIPs 157 and 158 in Bitcoin.
Yeah, and I mean, in terms of how it's different is that the vast majority of cryptocurrency projects, if they support SPV, they support server-side filtering and not client-side filtering. I believe it's Bitcoin and us and possibly Litecoin. I say possibly just because I know they have Lightning Network, but I don't know, you know, how far down the rabbit hole they've gone. But that's how it's different than a lot of other projects. Also, the thing that you'll see in a lot of other projects is that the the most widely used wallets are not the ones that necessarily support SPV. So in Bitcoin Core, for example, they don't support SPV. You need the full node. But what we do is that our sort of our current main implementation, DCR wallet that Jarek works on, is the one that we've built SPV into this, and we built it in optionally at first because it's not completely finished, and we can obviously get into the details of that a little later in the episode. But the upshot is that what we're doing differently is we do it client side, and we do it client side in the main implementation. So people can just download a wallet for Decred, and if it's backed by DCR wallet, which supports SPV, they can optionally turn on SPV and then, you know, gain all the benefits of SPV, as opposed to having to, you know, go get some sort of, you know, secondary client and then re-import all their, you know, all your data into it and so on.
Yeah, no, that's great. Is there a privacy concern when you're using SPV over just, you know, running a full node wallet and making transactions that way?
Yes. So there is so when you download in our implementation, you download select blocks, and those blocks supposedly have relevant transactions to your wallet. And that's more revealing of information about your wallet than downloading every single possible block. So right there is some privacy loss. However, this implementation is already far ahead of what has been used in Bitcoin and other cryptocurrencies for a very long time with the server-side filtering, because you're doing the local matching. You're not uploading a bunch of data saying, "Hey, these are my hash 160s for my addresses and all of my scripts and give me the transactions that match them. Instead, you're doing that check locally.
Yeah, I mean, from a privacy perspective, it's just a lot less data. So the thing you're trying to do with SPV is you're trying to minimize the amount of data that flows to the client without bleeding information about exactly which transaction the client is watching for. And, just like Jayrick pointed out, the client-side filtering does a pretty good job of that, which is, a passive observer can only see which blocks are downloaded. And, if we had link encryption for, P2P, then all they'd be able to see is that a connection was made, not even necessarily which block was downloaded. But the upshot is that if a passive adversary is watching our P2P network, the SPV links, you can see which blocks flow to who, but you can't see which transactions in that block someone is watching for. So from a privacy perspective, it's a lot better than most other, light or SPV wallets. And when I say light wallet, to distinguish it from an SPV wallet, I mean something that's centrally administrated through a central server that sends notifications when particular transactions come into your addresses. So from a privacy perspective, it's a big win, and it gets things onto mobile in a way that allows us to hit the ground running, as opposed to being like, oh, well, we have to develop a completely different from scratch client for mobile platforms.
No, that's great. One thing Jayrick or Josh had mentioned in regards to the transactions were Merkel roots and headers. Can you guys kind of break that down, boil it down for somebody who's maybe not familiar with what that means and why it's relevant to making sure that we can actually use a couple select blocks to actually verify a transaction?
Yeah, so every block has, in Decred, it's 180 bytes worth of data called the header, and that comes at the very beginning of the block. And this describes, it tells you your block hash, it tells you a Merkel root, which is the sum of all of the transaction hashes in the block, and it has the knots that was actually calculated by miners. And you're able to take that knots, hash up, find the hash of the block, determine that it's below, the required proof of work, or I guess above the required proof of work. And that's how you prove that, miners actually spent time working on this. There's economic, incentives to produce something that is valid. So that is what the light wallets check. They check to make sure the proof of work is correct. And then ideally, I guess we're going to be talking about this. They also check that the filters are correct. The filters are currently not validated. So you could have, nodes on the network that are sending invalid filters to light clients, and that's not detectable at the moment unless you download the full block, you compare the filter to the block, and realize, oh, this is wrong. So that's still an area that we are improving. We have plans to do this. Bitcoin is also, they have a solution for this as well, but we are not going to be using their solution because we're not afraid of hard forking to actually support this properly.
In terms of the pieces of data, if you're a person who doesn't normally get that far into the tech, there's two pieces that Jayrick is talking about here, right? There's the header that Jayrick has already mentioned, and that contains information like how much proof of work has been done. It gives you the ability to demonstrate that proof of work was actually done. And then it also gives you some information about the block so that when you download the block, you can verify it. And then it also gives you a sense of things like block number. So you can tell when the block was from, how big it is, how many transactions are in it, and all of these basic things, how many votes were on it. Now, the votes we don't get very far into with this SPV work, but then you download the filter, and then what the filter tells you is the filter is the piece that allows you to go, are my transactions or are any transactions that are relevant to my wallet in this block? So the headers allow you to verify that the chain is valid, and then the filters allow you to ask the question, for this filter, for this block, is there anything relevant in it to my wallet? And then by combining those two pieces of data, the headers allow you to verify the chain, and then the filters allow you to go, is this section of the chain relevant? So those two pieces of data allow you to go, do I download this block or do I not? And then so when you get a hit on the filter, you go, okay, oh, there's one of my transactions in this block. I'll download the whole block, and then it verifies it fits with the header that it corresponds to, and then it fishes out the transaction in question. And just like Jarek pointed out, there is there is a notable unfinished piece here, which is the header commitment for the the compact filters. And that's missing. And the worst case scenario you can hit using SPV right now is if somebody targets you and is creative, they can generate a false negative. That is, like, let's say I sent a payment to Jarek. Someone could, in theory, go, aha, I know Jarek's waiting for this payment. I'm going to send him a fake filter so that he misses it when the payment is sent. You can't fake a payment. So it's not possible for anyone to forge that I sent a payment to Jarek, but it is possible for Jarek to miss my payment. So in a worst case scenario, somebody's going to be like, oh man, I didn't get this transaction. Then they're going to go look at and somebody will tell them, go look at the block explorer, and then boom, that transaction's there. So that's the sort of the missing hole in terms of what works, what doesn't, and where the header commitments come in. Once you have the header commitments, you can no longer fake filters. That is, the filter hash is in the header itself, so that if anyone tries to generate a fake filter for a block, it ends up not hashing correctly to the hash in the header.
And that will be consensus validated with an upcoming hard fork.
Yeah, that's great. As far as the filters go, you guys were describing the compact filter that Decred is going to be using. Now, going a little bit back to the Bloom filter that Bitcoin uses, how are they different? And is Bitcoin's fix, or I guess they're what they're moving towards to improve it, is it going to be improving the Bloom filter? Is it something different?
So the solution in Bitcoin is quite similar. And they've actually been still working on this while we went and implemented it. And so they have some improvements that I would like to take and bring back into Decred as well. But this is all basically stuff coming from other Bitcoin developers. That being said, comparing it to the old way for Bloom filtering, this client-side filtering could be done with Bloom filters. You just, you commit to a Bloom filter, and then the client downloads the Bloom filter, and you do a Bloom check instead of a GCS check. GCS being the filter scheme that we are using. So it's not really comparing Bloom filters to other filters. It's the fact that we have the filters locally for the block in all transactions in the block, and then we're filtering that locally.
Yeah, and in terms of how this fits in with work that's either being done or already has been done in the context of Bitcoin, these client-side filters were proposed by the Lightning Labs people and contributed to by several Bitcoin Core developers. They've also made some updates to BIPs 157 and 158 over the past, few months?
Yeah.
And there's a few changes that Jarek has not yet pulled into the filters on our side. And then in terms of the things that are different, is it's really just a question of who knows what. Because if you do server-side filtering, people someone else can infer which addresses you're watching for, and then also infer which coins are yours and which are not, which is obviously bad for privacy. Whereas when you do it all client-side, it's much harder for remote nodes to infer which coins are yours and which are not. So in terms of, that's the big difference between these two. And then the other thing about Bloom filters that I guess we didn't mention was network traffic, right? I mean, am I right to say that there's a lot more network traffic with Bloom filters?
I don't know about network traffic. I do know that with the Bloom filter scheme, the client is able to specify a bunch of properties about the filter, like the false positive ratio, and that can cause a remote node to have to create different filters for the same transactions for a whole bunch of different clients, and that can be prohibitively expensive.
Oh wow! So it can really beat up the remote node. Okay. Yeah, there was what I do recall too about the Bloom filters versus compact filters was there were a lot of comments to the effect that Bloom filters were rushed into Bitcoin Core by Mike Hearn, and so there's a lot of also security problems with server-side filters. Just like Jarek pointed out, you can churn the CPU of the remote node pretty efficiently by throwing a bunch of filters at it, because just like he pointed out, these filters have to be updated and handled separately for separate clients. So it amounts to a means to DOS remote nodes, whereas on the client side, it's much harder to do. You know, you're hitting the same paths that end up getting hit when you're, say, syncing blocks. You know, you download headers, you download filters, and then in this case, you only optionally download blocks as opposed to just like, give me all the blocks.
Yeah, no, and that's great, and it's neat to see the implementation. Now, with it being from Lightning Labs, how does simple payment verification intertwine with the Lightning Network, or does it at all?
It doesn't.
Well,
this is just for on-chain transactions.
So that's correct, but I believe the real motivation for this was that the developers at Lightning Labs, what they did is they started with everything backed by a normal full node wallet, right, by BTC wallet. But what they found out in short order was they're like, oh my God, this is like, you have to sync the whole chain, so that the user experience was really crappy, right? You know, they're building on top of BTC Suite, which we obviously think is great. But then the user experience ends up being, download this thing that takes a really long time, and then you can finally spend your money. And so the SPV for them was a shortcut to let's just get a client up and running like lickety split, especially when you're talking about a client who literally just created a wallet. Like if you create a brand new wallet, in a lot of cases, you know, like full nodes will make you can't even really do anything with the wallet until, you know, the whole chain, or at least some of the chain, is synced if you're pruning. And that is mostly fixed with SPV. You can sort of snap your fingers, boom, you have a wallet, and maybe it takes 5-10 minutes to download the headers. And so that was really sort of the use case that they were gunning towards. Now, as Jarek pointed out, it really isn't related to LN, but it is from a user experience perspective. So technically it's not LN, but when they were talking about, well, how are people going to use this? They're like, oh man, we need an SPV wallet because they need the user experience to be, you know, closer to that of a credit card.
Yeah, and so making sure it's rapid and not another gauntlet of downloading a large amount of data. So it definitely makes sense. Now, a couple of the weaknesses that you guys pointed out were, you know, potentially being able to prevent someone from receiving a transaction, and then also, you know, with the Bloom network potentially bogging down the network, or being able to build some traffic in that regard. Are there any other weaknesses to SPV or reasons to not implement?
Well, I mean, it is slightly worse in privacy than running a full node, simply because you no longer have every block locally available. You have to actually ask peers for blocks, and then they might be able to still infer, you know, let's say if you download 5 different blocks, they can stream together a bunch of transactions that have been spent throughout those blocks. So the extremely paranoid people might still not want to use SPV. In Decred in particular, there's also some features missing for SPV, and that's actually sort of by design. So for example, a voting wallet will not be usable on an SPV wallet, because a voting wallet's responsibility is to vote on the validity of the last block. And to do that, you need not just the last block, but the entire chain to do it properly. So we don't support voting on SPV wallets. You can still buy tickets, but for voting, you're still going to have to run a full node.
In terms of shortcomings, I guess another thing worth mentioning about the ticket purchasing is that DCR Wallet itself will support ticket buying as of this coming release candidate that's going to come out. I think it's tomorrow, right?
Tomorrow or Wednesday, yeah.
Tomorrow or Wednesday. And so you can turn on SPV mode with DCR Wallet, and you can buy tickets. But the caveat is that with Decreds, which is sort of you know, it's roughly speaking, it's a process that talks to DCR Wallet, that won't support the SPV ticket buyer just yet. And the reasoning there is for UX reasons. We didn't have time to really sync to do the UX work to make the ticket buying nice and smooth for that. In terms
manually buying should still work. It's just the auto buyer
Ah, got it. Okay, so good clarification. Thanks for calling that out. In terms of weaknesses, I guess, yeah, just like Jarek pointed out, the paranoid amongst us, which often includes me and often includes Jarek, it is possible to infer things like what, for example, like what transactions you're watching for based on which blocks you're downloading. And we've actually had some sort of light discussion internally about this. And I won't share exactly what we've got in mind, but there are some ways to play games with this. Another thing that is worth pointing out is that at some point we will get TLS on peer-to-peer links. And when that happens, it's going to fix this passive observer problem quite a bit. Because what can happen right now is P2P traffic is unencrypted. So if I download some block from JRIC's DCRD, people who record the internet can see exactly which block. Once you have TLS in place, then it becomes a lot more annoying to record which block is being downloaded. So the only person who could possibly infer these things is one of the nodes that you're fetching blocks from, as opposed to someone who stores all your data underground on hard drives in Utah.
That's when you start sibling the network. Yeah.
Yeah.
Yeah, no, that's great. Thanks for that. And then noting back to this initial implementation where, once this client comes out, you can turn on SPV. But going forward, for a mandatory SPV wallet, why is there a need for a vote? What exactly is happening there?
So the vote is to support a change to how we are building our block header. We want to commit to that filter. We actually have two different Merkel roots currently in the header, one for regular transactions and one for stake transactions. That's kind of silly. We can put them all in the same Merkel root. So by doing that, we free up 32 bytes of space. We can put another Merkel root in there. And we can use that to commit to any data that we want, including filters. So that will require fully validating nodes and miners as well to create the filters, determine this commitment Merkle root hash, include that in the block header, and then solve proof of work for that filter and other data as well. And so that is obviously a hard forking change, and there will have to be some kind of vote to approve of this.
Yeah, and this is exactly what I was referencing earlier, and Jarek has also mentioned, is that when you get this filter, you take the filter, you hash it, and then you take that hash and you stuff that in the block header. So that then what happens is that, remember how we talked about the headers and the filters. You download the headers. Then as you're downloading the filters, you can verify that each filter is valid for the corresponding block header, as opposed to just going, well, it's probably valid because it's a waste of time for people to create fakes. And that's really the proper solution for these filters. Now I forget, are they referred to as compact filters or committed filters? Because I've heard both, and they both fit the acronym, right?
Yeah, I've seen both used as well. I call them committed just because we will be committing to them in the block header. I don't think compact properly describes what they actually achieve.
Fair point. Yeah, so I mean, these committed filters, technically they're uncommitted for now, but they will. Yes. We swear they'll be committed to soon. And more generally, just what Jarek was pointing out is, once we have that free 32 bytes in the header, we can take the hash of the filter and store it there. But then there's several other pieces of data or data sets that are very interesting on an ongoing basis. And we're actually planning to create a Merkle tree of these commitments, take the Merkle root of that tree, stuff that in the 32 bytes, and then what we would have is a group of commitments. And we'd probably start with the committed filters, but then there's other interesting stuff that can go in the header, like a UTXO set commitment, so that you can have a pruning wallet and know that you're not getting screwed in terms of what the UTXO set is. So, for example, you could download a snapshot of the UTXO set at block, let's say 250,000, and based on that, you can look in the block header and go, I know that this is the correct UTXO set, as opposed to guessing. And that guessing, removing those guesses allows you to essentially keep a wallet that doesn't even remember most of the blockchain. And you just make sure the headers fit together. You look at the UTXO set commitment. And then there's several others, just like Jarek was pointing out, say with voting. One of the issues with an SPV wallet is it can't vote, because in order to track the ticket pool state, you need all these other you need all this other data. Well, we could potentially put a ticket journal commitment in there, and then you can infer things like what is the status of the ticket pool by only going back so many odd thousand blocks, as opposed to downloading the entire blockchain. So that's sort of, that's where the commitment thing is going, and it's actually just like we've both been discussing, much more general than filter commitments. It can go well beyond that.
Yeah, and that's great, especially with the ticket piece being able to eventually be added in. Now, as far as this going to a consensus vote, is there a time frame from from when this is actually going to get into the point where you can turn on, turn it off, to when it is fully implemented and it's always on?
I don't think we have any timeline for this in particular yet. It's quite a bit of work. Dave C will tell you that.
Yeah, I guess that's more what I was asking. Is this something that just really requires, like, okay, once we're at this point, we just need the vote in order to condense the headers into allowing those bytes to be freed up, or if it was more intense than that? So it sounds like it's a little more intensive.
Well, anytime you're doing consensus changes, you have to really get in there and be surgical. Just like Jarek was saying, right? There's 2 transaction trees right now, and there's a separate Merkel root for each transaction tree. Those have to be merged, and that itself is a good chunk of work. Not only do you have to merge them, you have to make sure that it doesn't break anything else. And then once that space is open, then you need to add the commitment process, and then we need to make sure that that committing the filter hash is quick enough that it doesn't slow down proof of work miners, and then it all needs to be tested to hell and back. There's a lot of work that goes into this, but in terms of tangibility, it's very tangible. And for example, Dave C knows exactly what needs to be done, but it's really a question of sequencing. Is it important enough to do, say, right now versus 3 months from now? What we're probably going to lean toward something that we're going to shoot 20. Dun dun dun.
Are you back? Looks like it.
Did I drop?
I think so. I don't know if it was on my end or such.
I saw it as well.
No worries. Don't worry.
Yeah.
It's a computer conspiracy.
Do you mind repeating that piece about Dave C? Just kind of the prioritizing the different objectives?
Oh yeah. In terms of priorities, I mean, we obviously want to get this stuff into the headers, but it's notable work, and there's an opportunity cost to it. We're still trying to get Lightning, or Dave is really trying to get Lightning Network out the door, and that's a huge thing to push, and he's pushing it pretty much entirely by himself. And with that in mind, the question, it's all about opportunity cost. Would we rather have that versus something else? And so my read is it's several months out, and it'll happen. I'd say I'd be surprised if it didn't happen before the end of, say, Q1 2019, but that's just, it's really hard to say. Committing to timelines is one thing that I've found is very, very difficult when it comes to dev work, because there's just so many gotchas. Like, for example, Jarek didn't realize that the SPV rat hole was quite as deep as it was until he got in it, right?
Right.
Yeah, no, and the reason I asked that is just, again, to reflect to the community that, these things, even though, we look at Company Zero's 2018 roadmap, these are generally the working pieces that are happening. But, committing to a hard timeline is difficult, because for a lot of these things, you guys are the pioneers. These are things that haven't been done yet, and it's code that's having to be written from the bottom up. As far as SPV goes, I think we touched a little bit on what's coming forward, what that consensus change is going to require, and a general idea of what is to come in the future. Are there any other comments on SPV and how it relates to Decred that you guys wanted to touch on?
More mobile wallets in the future, I suppose. More accessibility to more people.
Okay.
I mean, that's kind of the goal there.
Yeah, and so with that, mobile wallets are a big deal. People have been wanting them for a while. SPV, is that a pretty easy transition to, let's say an Android or iOS mobile wallet?
It should be, yeah.
Yeah, I mean, there are some contractors working on this, right?
Yes. The other thing is we will probably end up phasing out the web wallet, just because when we have light wallets, there's not much point for us to run a web wallet. So.
Yeah, I mean, from a usability perspective, it's going to be a huge improvement. We'd obviously like a more diverse ecosystem, but right now we have one main implementation of Decred, and it's really excellent to be able to have something like DCR Wallet that runs on both workstations and laptops, but also on mobile, because then it's sort of a one-shot solution to be used across these various platforms. And we're lucky enough to have the ability to get this onto mobile without too much difficulty. However, the entire front end when you're on mobile has to be redone. We had experimented with taking Decrediton and making it run on mobile, but the UI components were just too slow and did not run right, and just overall the way it's architected for a workstation or for an end user system that isn't mobile, that just didn't work on mobile. So Rada Group is one of the corporate contractors we work with, and they have been working on the front end pieces so that it's basically DCR Wallet, which JRick is the lead dev for, and with some shims in place, and then a GUI over that's built specifically for mobile so that it's responsive. You mash the buttons and things happen, as opposed to you're running Decrediton and it's like molasses slow.
Yeah, no, most definitely. And I know everyone is really excited about the mobile wallets, but that is a key point, is making sure it's actually usable versus just the fact that you can get your transactions on the phone or on the mobile device that you'd be using. So that's huge. Before we get kind of the Q&A, because there's some people asking questions on the YouTube side of things, is there anything else notable that you guys wanted to comment on, just as far as the Company Zero's development overall? And Jake, that might be more something that you can speak into, and JRick as well.
Well, I mean, in terms of where things are going, is we're making good progress. SPV is pretty much in production at this point. The piece we're missing is the commitment, which I feel like is a separate deliverable. So all the SPV infrastructure is in place at this point. There's going to be some minor things that JRick tunes up over the next few months. Things like pulling in the latest updates from BIP 157 and 158, and then there's also going to be I totally spaced on what I was going to say next. But there's SPV, and then there's Politeia, and then there's a couple other things in the pipeline. Like LN has been sort of imminent for a long time. I swear it'll show up eventually. But Politeia, in terms of voting for stuff on mainnet, that is really not very far off, and several of the other things on the roadmap are going to pop in short succession. Which I'm very excited about, because being in charge of what we do with our dev org fund it's a heavy stone, and I would really like some help.
Jake, a lot of people comment on Jake being the CEO of Decred, or the big boss of Decred, and I'm sure it's not the easiest thing to bear, because as far as how and maybe you can touch on this a little bit, as far as how the contractors and how the development fund, or forgot what Chris Berninsky called it, the network fund, which I really like the wording of that. What is that going to change? Is that going to be coming with Politeia, or is it something that's going to be a little bit separate for how those funds are more decentralized?
Oh no, that's exactly what we're getting at with mainnet Politeia, which is that the ultimate control of the funds and what we do with them. I think I don't know. I don't even know exactly how many there are right now. There's like 500,000 of them that have been accumulated. Is right now the decision making process is people will come to me and go, oh, I want to do this, or I like working on this. Is there, can I get paid by doing this? And we typically go, okay, well, show us your stuff, and people will demonstrate their domain knowledge in one domain or another. And then if we like their work, then we offer to pay them on a rolling basis for it when they invoice us. Now that process obviously doesn't scale so great because I'm one dude and I'm already sort of, I'm working with devs at C0, and I have other things that I do. So managing dozens of people who show up and they all do different things is really non-trivial. So what our hope is that we open that up, and then people can make proposals, and their proposals will get funded. And the thing we're going to see is that unless it's a very serious problem or a very problematic use case, I will be ceding sovereignty over these funds to the stakeholders. So stakeholder votes will be sovereign, and as long as I won't get in legal, as long as I won't be put in legal jeopardy for releasing the funds, when stakeholders vote on it, it's good to go. Or if I feel like it's going to wreck the project, I may veto it. But I would almost rather let it detonate on its own, so that everybody can sort of see what happens. So that's, from a spending perspective, those funds that we've accumulated, we've been very, very thrifty. I think we spent like 15 to 18% of the total subsidy. So the bulk of this subsidy is going to be, directed by the stakeholders on an ongoing basis once Politeia is up.
Great. And then one piece, just so people don't get nervous, what did you mean by veto the
Let me give you an example. Here's an example, right? There are certain things that I, as a U.S. citizen, cannot do without putting myself in legal jeopardy. For example, let's say, and this is obviously an extreme example, let's say there's a religious extremist group that makes a proposal that says you should fund our foot soldiers in the revolution to take over country X. I cannot release funds to do that because that will put me in serious harm's way. So there's certain things that I will have to veto from a perspective of, this could put me in jail, so I'm not going to do this. And then there's also going to be, in the off chance, and this, I say it's off chance, what is it? It's an unknown. I don't know what's going to happen, and I guess neither do any of us. But it is conceivable that someone makes a proposal that would break or wreck Decred. While I'm the person who's releasing the funds, I would be very inclined to stop that, but it would have to be an extremely dire circumstance for me to veto it. I mean, that's why I'm putting that out there. Is it's sort of a don't sink the ship veto. Not so much a Jake doesn't like it veto. Hey, if I don't like it, it's still going to go out. But if it's going to sink the ship or possibly sink the ship, I may veto. But that's what I mean. Is it? And this won't last for very long.
Yeah, and that was going to be my next question. Is this something that would be like do you have that permanent power, or what would be the stage of that being relinquished?
We're going to take these funds and we're going to stuff them in a smart contract so that the stakeholder votes on, there would be let's say an end of month event where all of the various contractors get paid out, and all of the payments would be prepared and audited and looked at by several other people. Then it would be put up for stakeholder vote. Then, maybe several days after that happens, everybody votes, boom, the funds are released. So at that point, once the funds start flowing into that smart contract, the veto will be gone. There will be no veto. So, and the other thing that's nice about that is that if the stakeholders vote to do something that's legally questionable or would have otherwise put me in legal jeopardy, I am no longer in legal jeopardy. It's a smart contract, and they'll have to put that smart contract in jail.
No, that's great. And I appreciate you clarifying that, because I know that some people's, big issue with Decred is just like, only a select people have this power over this network fund or development fund, whatever you want to call it. And, they're never going to truly relinquish power. But to your point, once it's given over to, input into that smart contract, the stakeholders are really going to have the final say on what money goes where. So that's important. But yeah, let's get into some of the questions that have been coming up. The stakeholders are really going to have to the state. Yep. Am I still here? Sorry, yeah. Okay, let's see. So one person asked, if they switch on SPV and Decred, can they delete the blockchain database from their device?
Yes, assuming you don't want to run DCRD anymore. You won't be able to switch back to the RPC syncing mode without re-downloading the chain.
Great. Another person asked, and I think we kind of touched on that, what the confidence is in the 2018 roadmap, primarily if anything has changed and if there's any other resources necessary to meet those criteria within 2018.
I think the thing to keep in mind with the roadmap, and I tried to condition people's manage people's expectations with this roadmap as compared to the 2017 one, which is that we make a good effort to get all of the work done, but something that's easy to forget, especially if you're not a software developer, is that come up when you're doing this work. The rat holes get deep and they get wide, and it requires a lot of work. For example, I think JRIC and I did not expect SPV to take quite as much work as it did. And if you look at the work when it came in, how big was it, JRIC? It was like minus 3,700 plus 7,500 or something for
Probably
lines.
Close to that. I don't remember exact numbers.
Yeah. So there was a whole bunch of work that was needed to get SPV in. So when we create a roadmap, we try to talk about the things that we believe we can reasonably complete in a year, but it's not it's not a commitment in the sense that everything that was on the 2017 roadmap did not happen in 2017. However, 2/3 to 3/4 of it got done. And then I expect similarly for the 2018 roadmap. We make a best effort to get as much work done as we can, but the world is a challenging place, especially in the context of cryptocurrency, because there's only so many people who can do this work. Not only are there only so many people who can do this work, there's only so many people who are tenacious enough to do the work. So there's a lot of people who are capable, but they just don't have the huevos to step up and do it. The other thing is that there's a lot of hot money in the space. So it's not like you could, there's easily 100 projects that have $10 million plus that they could wave around and go like, I'm going to get, I want all the best developers because I got a pile of money. And so the money doesn't make these people show up. The people have to show up because they want to show up. So the amount of work we complete is, we try to estimate what we can realistically get done. And sometimes it's closer to what we broadcast, and sometimes it isn't. So I'm estimating we'll get 2/3 of the roadmap done in 2018.
No, that's great. And I know people appreciate the clarification. And yeah, it is a lot of work. One thing I do want to say is Dave had a great comment in the chat, just again, going back to the vetoing, just for the people that are still maybe not understanding or worried. He just said, it's worth noting that the next big piece of the decentralization is putting the funds into a DAE, which is fully controlled by the stakeholders. And then at that point, there will no longer be a veto. Because I think just the word veto and one person vetoing does make people nervous. So again, I just wanted to clarify on that piece.
Yeah, I mean, something else that I figure is worth pointing out here is that look at how we've managed the funds to date. We've been extremely thrifty. Company Zero performed work to bring up the network from February of 2016 through the end of April 2017 without charging anything for that work. And that was really because the network fund did not support or could not support the work we were doing, because it cost far more than the exchange rate would really admit. We're not here to take all the money or do anything really wacky like that. But what I'm doing is that, and this has been going on ever since we started the network, is we're ceding sovereignty on a steady basis. We started out with 50% of the sovereignty. Now it's down to 20%. And then over time, it's going to keep dropping. And from a formal perspective, we're already far more decentralized than most of these other projects, just in the sense that we're going to implement a system that has formal sovereignty mapped to stakeholders, and we've already backed away from it. The other thing that people forget is that technologically speaking, everybody wants, something, everybody wants a robot that does their laundry and makes them sandwiches and cleans their house and, takes care of their kids and does all these things. But the reality is that you can't, you can't automate things like that. You have to automate them one piece at a time. So we're getting to the point where this robot will run by itself, but we're not quite there yet. So as much as people are like, oh, the project isn't very decentralized, well, it takes time to build these things. Rome wasn't built in a day, and neither was the United States. So, if you look back at when people were writing the Constitution and the Bill of Rights, this stuff took years. It wasn't like, oh, here's the Bill of Rights, boom, we're done, guys, let's all go home.
Yeah, and I think that's very much the culture of the cryptocurrency space right now, is just if it's not done in 6 months, it's never going to happen, or off to the new and shiny object. And I think it is really unrealistic when you're building these core fundamentals foundationally that are going to support a DAE, that are going to support a true DAO. And I think that really is worth clarifying. Another question, which it seems to be the most common one. Any ideas or hints or glimpses at the privacy implementation?
I think that you'll be surprised, and it will be happening soon. I swear.
Great. Well, I think that's basically it. Some of the questions, that were asked, we did cover in the show. So I recommend going back and taking a look at what we covered. But yeah, unless Jake or J-Rick have anything else to comment on, I think that's about it. Anything, guys?
Nope.
Cool. Well, thank you so much for your time, and it's a good episode. We're excited to see SPV come in the next day or two, and yeah, excited for the things to come in the next few months. So thanks again, guys.
No problem. Thanks for having us.
Thanks for having us, Trace. Always a pleasure.
Yeah. All right. Have a good one, guys, and thanks again for tuning in.
You too. See you.